guys, welcome back to my YouTube channel. I hope you have a fantastic Hari Raya break, so you're now fresh to continue with our chapter 4. So in this chapter, we are going to divide it into two parts, part 1 and part 2. So today we are going to discuss on the class activity for part 1. Altogether, we have two different questions, and let's get started with the first one. Question number 1. A quantity of HI was sealed in a tube heated at 425 degrees Celsius and held at this temperature until the equilibrium was reached. The concentration of the HI in the tube at equilibrium was found to be 0.0706 mole per liter. Calculate the equilibrium constant of H2 and also I2 for the gas phase reaction below at 425 degrees Celsius if the Kc is equivalent to 54.6. So how are you going to do to tackle this kind of question? According to the question, you were given the chemical equation which is the hydrogen plus iodine will produce 2HI. So in order for you to answer this question, you need to write the ice diagram. So initial, change, equilibrium. So in the ice diagram, you need to know what is the initial concentration of the reactant, which is not given to you in the question. So X, and there will be no formation of product in the initial state of the reaction, so 0 here. So as the reaction proceeds, some of the reactant shall be used in order for you to produce the product. Therefore, we have negative Y, positive Y. Right. So here, when you look again at the equation given to you, you have 2HI. So instead of Y, you need to write positive 2Y. Right? Because you have 2 over here. So at equilibrium, you need to do the summation of all the things that you have at initial and also at change. So X minus Y, and also positive 2Y. Alright. So next up is you need to write the Kc. So the Kc, how you should write is whatever in the product divided by whatever in the reactant. So you have 2Y over here. Since you have 2, so it means that you have to have the power of 2. And since you don't know what is the initial concentration, so we assume that the value of X is actually negligible. So you have negative Y times negative Y. So if you read again from the question, the value of Kc is given to you, which is 54.6, and the value of 2Y, whereby in the question it states that the concentration of the HI in the tube at equilibrium was found to be 0.0706 mole per liter. So it means that the value of 2Y is equivalent to 0.0706, right? So to the power of 2 equivalent to Y square as well. Because negative become positive. So what you need to do is that you need to find what is the value of this. So you get 54.6 is equivalent to 4.9844 times 10 to the power of negative 3. So you can bring this y square over here. Therefore, your y square is equivalent to 4.9844 times 10 to the power of negative 3 divided by 54.6. So you should get y is equivalent to the square root of 9.1289 times 10 to the power of negative 5. So the final answer is 9.5545 times 10 to the power of negative 3. So in the question, you were asked to find what is the concentration of the H2 and also the concentration of I2 at equilibrium. So the concentration of H2 at equilibrium supposedly is X minus Y, right? But since we don't know what is X, and a concentration can never be a negative value because it's a concentration, so we assume that the concentration of H2 is equivalent to 9.5545 times 10 to the power of negative 5, which is also equivalent to the concentration of the I2. Alright, so what I need to tell you is that please do not get confused, because you say that you already know the value of 2y is equivalent to 0.0706, but please do not assume that you just can find the value of y by doing this. You shall not get the same answer. This is absolutely wrong. Alright. Moving on to question number 2, at equilibrium and 727 degrees Celsius, the Kc of the reaction below is 4.08 times 10 to the power of negative 3. So determine what is the Kp for this reaction. From the question, you were given the chemical equation 2SO3 will produce 2SO2 plus oxygen, and you were asked to calculate what is the Kp given to you, Kc equivalent to 4.08 times 10 to the power of negative 3. So, when you want to find the Kp, you need to merge this Kp and Kc together. Then you will get the formula is Kp equivalent to Kc RT delta N. Alright, so from here, what you need to calculate is the delta N. So the delta N is whatever in the product minus whatever in the reactant. So the product we have 1 plus 2 minus 2. Okay, in this question, I didn't write to you the state of the matter. So usually people will write the state of matter whether it's aqueous, gas or solid, but if you were not given this, so you should be able to decide whether oxygen definitely is gas, SO2 is gas, and SO3 are gases as well. So you are going to use all of this, so you get the delta N is equivalent to 3 minus 2 equivalent to 1. Alright. Okay, moving on. So since we already know what is the value of the delta N, next up we need to find the value of T. So T is the temperature. Given in the question, the temperature is 727 degrees Celsius. So you need to change this to Kelvin. So you need to plus 273. So you should get 1000 Kelvin. Alright, so we have managed to calculate the value of N and also the value of T. So now we can calculate the value of Kp. So which is Kp equivalent to Kc RT delta N. So Kc is given in the question, which is 4.08 times 10 to the power of negative 3. And then the R is a constant value for gas, so 0.0821 times temperature, which is 1000 Kelvin, and then your delta N is equivalent to 1. Therefore you should get your Kp is equivalent to 4.08 times 10 to the power of negative 3 times 82.1. Therefore you should get Kp equivalent to 0.3349. So this is the final answer.